Welcome to AI Frontiers, where we decode tomorrow's technology today. Today we're exploring the AI language revolution of November 2nd, 2025, featuring 16 groundbreaking papers in computational linguistics. These research advances span multilingual AI systems covering nearly 200 languages, specialized tools for medicine and climate science, and new approaches to AI reliability and bias reduction. We're witnessing the breaking of barriers between human thought and machine understanding in ways that seemed impossible just years ago. Our journey begins with a startling paradox that challenges everything we thought we knew about AI capability. The most advanced AI models, the ones that seem almost human in their performance, harbor a dangerous flaw. They're catastrophically overconfident. When researchers tested these systems on complex reasoning tasks, they discovered that Gemini 2.5 Pro, despite its high accuracy, showed only 4.34% self-awareness when making mistakes. In stark contrast, the lower-performing Llama 4 Scout demonstrated 42.09% error recognition. This means our smartest AI systems are paradoxically the worst at knowing when they're wrong. A discovery with profound implications for deploying AI in high-stakes situations. Today's computational linguistics research represents the ultimate translation project, bridging human thought and machine logic across 16 remarkable papers. These studies tackle everything from Romanian medical records to NOAA satellite data, from solving ancient riddles to building future AI systems. We're witnessing the transformation of science fiction into daily reality as researchers decode tomorrow's technology for today's applications. This collection of work shows how rapidly the field is evolving, moving from impressive demonstrations to practical tools that can genuinely assist human intellectual endeavors. Computational linguistics functions as the ultimate bridge-building project between two distinct worlds. On one side, we have humans with all their linguistic complexity, cultural nuances, and creative expression. On the other, machines that process information in binary logic. This field represents the engineering marvel of constructing bridges between these worlds, operating like a bustling international airport where linguistics, computer science, and artificial intelligence converge. What makes this moment particularly exciting is how the field has evolved from distant science fiction to daily reality in just a few short years, while simultaneously democratizing language technology beyond the traditional dominance of tech giants. The first major theme in today's research focuses on breaking language barriers globally through multilingual and cross-cultural processing. This represents a crucial shift away from English-centric approaches that have dominated AI development. Romanian language model research demonstrates that quality trumps quantity in data curation, achieving superior performance through careful filtering rather than simply accumulating massive datasets. Meanwhile, the HPLT-3 project represents an almost unimaginably ambitious effort, creating training data containing 30 trillion tokens across nearly 200 languages. This work fights against linguistic colonialism in AI development, ensuring that language technology serves the full spectrum of human linguistic diversity, rather than privileging wealthy, English-speaking populations. The second theme transforms AI systems from Swiss Army knives into surgical scalpels through specialized domain applications. Rather than building general-purpose systems that know a little about everything, researchers are forging precision tools optimized for specific domains where accuracy matters more than versatility. VayuChat exemplifies this approach with air quality analytics, while OceanAI creates direct connections to NOAA oceanographic data. These systems move beyond general-purpose capabilities toward genuine domain expertise, providing verifiable information rather than plausible-sounding but potentially incorrect responses. This specialization represents a maturation of the field, recognizing that different applications require different approaches. The third theme encompasses evaluation, training, and efficiency advances that might sound technical, but are crucial for progress. The TSVer benchmark addresses fact verification against time series data, filling a critical gap in how we assess AI capabilities with temporal reasoning. Prompt R1 uses reinforcement learning to teach junior AI systems to ask better questions of senior models, like training a research assistant to interact more effectively with experts. MARS-SQL employs multi-agent coordination resembling restaurant kitchen operations during dinner rush, Meanwhile, advances in sparse attention mechanisms achieve 50% memory reduction, while actually improving performance on long documents, challenging conventional wisdom about how attention should work in language models. 6 game-changing discoveries emerge from this research collection, each reshaping our understanding of AI language systems. First, overconfident models paradoxically struggle with self-awareness, as demonstrated by the riddle-solving experiments. Second, quality data curation consistently beats massive datasets, as showed in Romanian language modeling. Third, multi-agent systems outperform monolithic approaches through specialized coordination. Fourth, real-time data grounding enables verifiable AI responses rather than hallucinated information. Fifth, alternating attention patterns improve long-context modeling while reducing computational requirements. Finally, contrastive learning approaches can effectively reduce social biases without sacrificing general performance, pointing toward fairer AI systems. For our paper of the day, we spotlight the TSVer benchmark by Strong and colleagues, addressing fact verification against time series evidence. This work tackles a critical gap in how we evaluate AI fact-checking systems, moving beyond static claims to dynamic data relationships. The researchers collected 287 real claims from 38 professional fact-checking organizations, spanning economics, health, climate, and politics. They curated 400 time series across these domains, creating a comprehensive foundation for testing AI systems' ability to verify claims like unemployment has been steadily decreasing, or this has been the hottest summer on record. This benchmark addresses the growing need for AI systems that can analyze temporal patterns and numerical relationships rather than simply looking up static facts. The TSVer benchmark reveals significant challenges in current AI systems' temporal reasoning capabilities. Even the best-performing model, Gemini-2.5-PRO, achieved only 63.37% accuracy on verdicts, with an EV2R score of 48.63 on justifications. This represents a substantial performance gap compared to these same models' achievements on other language understanding tasks. Claims requiring trend analysis, like unemployment steadily decreasing, demand systematic evidence-based reasoning that current language models struggle with. The researchers achieved kappa equals 0.745 inter-annotator agreement through AI-assisted annotation, validating their benchmark's reliability while revealing the significant gaps in current language models' analytical capabilities. TSVer's impact extends far beyond technical benchmarking, addressing the misinformation crisis through evidence-based AI fact-checking. The benchmark's detailed justification annotations enable research into explainable AI systems that provide clear reasoning for their decisions, not just binary verdicts. This transparency is crucial for building public trust in automated fact-checking systems. When an AI system evaluates a claim's truthfulness, users need to understand the evidence and reasoning behind that conclusion. The work provides a foundation for developing hybrid systems that combine language models with specialized time series analysis tools, creating AI fact-checkers that are both conversationally fluid and analytically rigorous. This approach directly addresses the need for objective evidence in combating misinformation and supporting informed democratic discourse. Looking toward the future, computational linguistics resembles a caterpillar entering its chrysalis, with only hints of the butterfly it will become. The convergence of multilingual capabilities, specialized domain applications, and more reliable reasoning suggests we're approaching a new era where AI language systems will be true partners in human intellectual endeavors rather than just impressive technical demonstrations. The trajectory toward multilingual and culturally inclusive AI promises to democratize language technology across the world's diverse linguistic communities. Imagine farmers in rural Bangladesh getting agricultural advice in their native language, or researchers in Nigeria accessing global scientific knowledge without language barriers. The emphasis on grounding AI systems in authoritative data sources points toward a future combining natural conversational ability with the reliability of traditional information systems. The path forward in computational linguistics emphasizes building tomorrow's language intelligence through several key principles. Quality consistently outperforms quantity in multilingual AI development, as demonstrated by Romanian language modeling success. Specialized tools systematically outperform general-purpose systems when precision matters more than versatility. Self-awareness and bias mitigation remain critical challenges, with overconfident models posing risks in high-stakes applications. The future lies in collaborative, explainable AI systems that can provide transparent reasoning for their decisions. Multi-agent approaches show superior performance through orchestrated collaboration rather than monolithic architectures. These advances collectively point toward AI systems that combine conversational fluency with academic-level accuracy and reliability. This research summary was created through AI synthesis using Claude Sonnet 420250514 with TTS synthesis powered by Deepgram technology and image generation through OpenAI systems. The content underwent human expert review, though we acknowledge the potential for oversights in synthesizing complex technical research. All original research references are provided for verification, ensuring listeners can access the primary sources. This hybrid approach of AI synthesis with human oversight represents the collaborative future we've discussed throughout today's episode, where AI tools enhance rather than replace human expertise in understanding and communicating complex technical concepts. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates on cutting-edge AI research insights, expert synthesis of complex technical concepts, and join our community exploring the future of artificial intelligence. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv-preprintserver.org, content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv-preprintserver.org.